Okay, we're going to take a look at analytic methods. Analytic just means a way of using algebra, different strategies other than tables and graphs. So we're going to try factoring, simplifying, which we've already looked at, and also using the conjugate. So it says, in the previous adventure, we learned to use substitution when possible. We also learned that substitution does not work at a hole in the graph. There are 3 techniques that can be used to find limits as we approach holes. And 0, 0 is called indeterminate form because as we approach 0 in the numerator and in the denominator, different things can happen. And later in the course, we'll look at other indeterminate forms using infinity. So we've already looked at this, so this is a good review. Factoring. A hole is referred to as removable discontinuity. This term indicates that we can use algebra to find the y value of the hole. Be aware that in many calculus problems, the c value that x approaches may give us a hint for factoring. The c value is this number right here, x approaching 3. So that makes the denominator undefined. So therefore, a factoring hint for the numerator is to find a factor of x minus 3. So we are going to look to factor the numerator. If you want to think of it using the diamond method, 3 would go in the top of the diamond and -4 would go in the bottom of the diamond. What are the factors of 3 that add up to -4? -3 times -1. So our factors are x minus 3, x minus 1, and I have x minus 3 in the denominator, which now cancels. So now to evaluate my limit, I plug in 3 for x. 3 minus 1 is equal to 2. So my limit is equal to 2. I could not find the limit until I canceled out that x minus 3 term from the denominator, because currently the denominator was 0. All right, example 2. So again, when I try to plug in 5, you can see that I'm going to get 25 minus 25, which is 0 in the denominator when I plug in 5. So I'm going to factor. It looks like the numerator is difference of squares, x plus 5, x minus 5. The denominator, I'm looking for the factors of -10 that add up to -3. -5 times +2. So the x minus 5 will cancel, and I will have x plus 2 left. Now I'm going to plug 5 into the numerator and denominator. 10 over 7. So my limit is 10 over 7. All right, and example 3, if you're unfamiliar with how to factor this, remember we want to plug in 0 and we can't. So that gives us a hint for factoring. What factor do I need to factor out? A factor of x, greatest common factor. So this would be x times x plus 2, and I have 3x in the numerator. So this x is allowed to cancel with this x. So I have 3 over x plus 2, and I'm going to plug in 0 for x. So my answer is 3 over 2, or 1.5. So these were all factor, cancel, plug in. All right, so it says sometimes you may need to do some simplifying before factoring is possible. So if you notice, I can't just factor here because I have this x minus 3 squared term, but I also can't just plug in 0 in the denominator. So what you're going to do is actually FOIL out x minus 3 times x minus 3, and then subtract 9 to simplify the numerator first. So I would have x squared, because x times x is x squared. My outer and my inner gives me a total of -6x. And then -3 times -3 is +9, and I'm still subtracting 9. This adds up to 0. So my numerator is x squared minus 6x. My denominator from up above was still x. So now I can factor the numerator by taking out a greatest common factor of x. So I would have x times x minus 6 all over x in the denominator. Now I can plug in 0. 0 minus 6 is negative 6. All right, example 5. So now I'm going to be simplifying the numerator the same way I did over here by using FOIL, canceling, factoring. See if you can pause the video and try example 5 on your own before I work it out. All right, so I'm going to do it out now. 7 plus h times 7 plus h is 49. 7h and 7h is 14h plus h squared, and then I've got that minus 49. This adds up to 0. I have 14h plus h squared all over that h up here. Now I'm going to factor out an h. H times 14 plus h is what I would have left in the numerator. Cancel my h's. Now I have to plug in 0 to find the final limit. So the final limit is 14. All right, so here is kind of the third method for today. So we had factoring, then we tried just simplifying first and then factoring. So now this is when there's a square root symbol. These limit problems are usually going to be set up to work with a square root symbol using a conjugate. So it says recall that the conjugate of a binomial with a radical or radicals can be used to eliminate the radicals. A similar method may be used to evaluate limits. So I just want you to go back to trig for a second here. When you had 3 over, let's say, the square root of 2, what did you do to get the radical out of the denominator? You multiplied by root 2 over root 2, because that's like multiplying by 1, so you're not changing the value of this fraction. So you end up with 3 root 2 over 2 as the rationalized but equivalent version. So you may or may not have gone into a little bit more complicated rationalizing in trig. What if you had 1 over, I'm making something up here, the square root of 2 plus 3. So this is now a binomial that's in the denominator. In order to rationalize the denominator, just multiplying by root 2 is not going to work this time because you'll end up with a term 3 root 2. So it's called multiplying by the conjugate. So root 2 minus 3 would have been the conjugate of this term. And then when you FOIL out this denominator, you end up with all of your radical terms going away because root 2 times root 2 gives you just 2. Your outer term plus your inner term ends up being opposites. So you get 3 root 2 and negative 3 root 2, which is 0. And then 3 times negative 3 is negative 9. So conjugates were used in trig. So maybe you remember that. Our goal here was to get the radical out of the denominator. Our goal here is to figure out how to get rid of this x minus 3 term in the denominator, but using the conjugate of the radical term is going to help us. So do you see how I cannot plug in 3? I should always try substitution first, but I can. I get 3 minus 3 is 0. There's nothing to do. I can't factor. I can't cancel. So that's when I'm going to try this method of using the conjugate because my brain sees this radical. So hey, maybe conjugate will work. I need the conjugate of this binomial term. So the conjugate is going to be the square root of x plus 1 plus 2. So this sign right here changes to a plus. The denominator gets that same square root of x plus 1 plus 2 binomial. So we're not going to multiply the denominator at all. We're going to leave the denominator x minus 3 square root of x plus 1 plus 2. And we're going to look at some magic that's going to happen in the numerator. What happens when you multiply a radical by a radical? The radicals essentially cancel each other and you are left with x plus 1. The outer term 2 of those radicals, and the inner term, negative 2 of those radicals, add up to 0. And last, negative 2 times positive 2 is negative 4. That makes your numerator now x minus 3, right? X plus 1 minus 4 is the same as x minus 3. So my x minus 3's cancel. Now I have 1 over this denominator. So I'm going to plug in 3 to evaluate my limit. 1 over the square root of 3 plus 1 plus 2. What does that give me as an answer? The square root of 4 is 2, and 2 plus 2 in the denominator is 4. So my answer is 1/4. So you could try example 7, or I will help you do it now. So here's this. So I've got the square root of x plus 8 plus 2. Square root of x plus 8 plus 2. Denominator stays the same, x plus 4, square root of x plus 8 plus 2. Square root times square root just gives me x plus 8. Outer, inner adds up to 0. Negative 2 times 2 gives me negative 4. That is equal to just x plus 4. My x plus 4's cancel, so I have 1 over all that stuff. And I'm going to plug in the number negative 4. Well, this is a coincidence. I have the square root of 4 again, which is 2. So my answer again is 1/4. 1 over 2 plus 2. I promise you the answer will not always be 1/4. All right, so you have 6 questions to complete, and I've given you a hint on this one. And then you've got problems using the 3 methods from this page that you will practice.